Welcome back to my little channel. Today I'm going to address flat earthers. And yes, I know that sounded dirty, but then again, in a way, they are. And to begin with, I don't care whether you believe the earth is flat or not, but to pretend that other people are being fooled to believe that the earth is round, the first question that comes to my mind is, who benefits from people thinking the earth is round? I mean, does it affect our everyday life, whether the earth is round or whether it is flat? The answer to that question is quite simple. No. I mean, we know the earth is round because, well, anyway, but whether it were flat or round doesn't make a difference to our day-to-day life. So why are you pretending that it does? That's not the worst of it, though. Some of the points they make to prove that the earth is flat are downright stupid. Now, that's just my opinion, obviously, so let's see if you can agree with me. I've been shown a list of things that are facts that prove the earth is flat. Walk with me through that list. Let's have some fun. Here is the list in all its grandeur. Well, it's not fair, but somehow some people think that these are reasonable questions to make them believe whether the earth is round or not. And you know what? Let's take this list and address them more or less point by point. So let us start with their first argument or fact or whatever you want to call it. I would believe in a globe if there were real photographs. Now, I will link a bunch of images of the world from the moon, but unfortunately, as you will see, you cannot see it's a globe. You can see it's a disc, but you cannot see it's a globe. That's the thing, though. I mean, if you make an image, a picture of a globe, it will no longer look like a globe because pictures are flat. They're 2D, two-dimensional, 2D. Yeah. So yeah, there is that. By the way, I will link you and all that. I would believe in a globe if someone measured the curve. Okay. Then I can make you believe right here and now, because I can measure the curve. You can too, by the way, don't worry. It's not that I'm that bright. We know the circumference of the Earth is about 40,000 kilometers. We also know that for a globe to be a globe, it has to be a full circle. So we know that the full circle is 360 degrees. So if we divide 40,000 kilometers by 360 degrees, we know how much 1 degree is, which would be around 111 kilometers. A little bit more than 111 kilometers. So it's fair to state that the curve of the Earth is roughly a little less than 1% every 100 kilometers. I will also show you how much of a curve that is, just to make it visible for you. This is the amount of curvature you will see in a 10-kilometer horizon. Now, the farther the horizon gets, the more curvature you will see, but this is the curvature you will see on 10 kilometers. Now, most people live in cities nowadays. You don't have the luxury of a 10-kilometer wide horizon. Never mind that, though. This is it. This one I particularly like. I would believe in a globe if someone showed me how water can curve and stick to a ball when it's not what we observe. Well, the thing is, there is already an explanation out there. It's called gravity. I'm sorry, I'm not going to explain gravity for you. But you know what? Read. Now, we can't really stick water on a ball because if we have a ball in our hands, the ball is affected by Earth's gravity. And we can't take away Earth's gravity to give the ball more gravity than the Earth. It's scientifical and all that, but actually it's not. It's quite simple. The bigger object has more gravity. That's basically how it goes. But I'm pretty sure that this isn't good enough an explanation. So yeah, sorry, I can't get you a better explanation than this. Reality sucks like that, doesn't it? It doesn't go along with our perceived realities. It should. I would believe in a spinning globe if motion was detected and the constellations changed. Okay, this is a little bit difficult because motion is detected, but it's not detected by us. We don't notice it because we are within the Earth's gravitational pull and the Earth moves for us. And the constellations do change, but we don't notice it. It's happening at such a huge distance that we don't see the movement they make. We can't see grass grow, and trust me, that changes a lot faster than the constellations. Well, not really. The constellations move a lot faster than the moon and the grass, but they do so at such incredible vast distances from us that we do not notice it. We can measure it over a period of time, but yeah, you can measure a lot of things over a period of time, but that doesn't mean you can see it. And somehow, measurements you don't believe in, because we measure the spinning of a globe. We measure the detection and the movement of it all. But that's not good enough. So I would believe in a spinning globe if motion was detected. It was. And the constellation changed? They do. Do you now believe? Yeah, I know, it's getting a little bit silly because I would believe in a globe if the stars didn't circle above us perfectly. But they don't. Part of the explanation of why the constellations are constantly changing is also why the stars are constantly changing. Because they are. But it's at such a long distance away from us that we don't notice it. It's a scale thing. But we do measure it. There are differences. It seems more and more that flat earthers aren't really interested in trying to understand how the world is, but are more and more interested in denying that the world is the way it is. I wonder why. This one is nice too. I would believe in a globe and satellites if it wasn't 2000 degrees Celsius where the ISS and satellites are supposedly. Well, you're the one assuming it's 2000 degrees there. Can you substantiate that in any way? Because what we in the rest of the world know is that there is an absolute minus temperature, and it's probably closer to that than the positive temperature. And on the side where the sun shines on the ISS, it will get hotter, but nowhere near 2000 degrees. I mean, where do you get that number from? This one is particularly funny to me. I would believe in a globe if not for sundials, astrolabes, and gyroscopes. And the funny thing is that a sundial only works because we are on a globe. Because we are on a globe, the sun is at different angles from us, and the shadow then can roughly estimate the time, predict time, how you want to call it. But it depends on where you are on the globe. So for example, 3 o'clock on the meridian looks very different than 3 o'clock in Norway. But in both situations, the sundial does usually work. Astrolabes are a crude device to navigate by the stars. Okay. So what does that prove? You're measuring your position based on the position of other things millions and millions and millions of light years away from you. Well, not millions, well, some of them millions of light years. Never mind that. And then there are gyroscopes, which basically more or less predict movement. I have no idea what that has to do with a globe. I mean, if nothing else, a gyroscope tends to prove that objects in motion prefer to stay in motion. But that's about it. And yeah, to be easy at motion, it will level itself out. And that leveling itself out thing is based on gravity. Seriously. If for anything, these items prove that we're on a globe. This one I understand a little bit better. I would believe in a globe if the Coriolis effect actually worked, but I've seen different results in the same hemisphere. Unfortunately, I understand him, but it also proves that he doesn't really understand the Coriolis effect. For example, the story that water goes down the sink or the drain differently in Australia than it does in the other side of the world, it's partly true, but that's not the whole thing of it. Now, I will have a link downstairs explaining the Coriolis effect, and I would advise people to read up on it. But if we're talking about sinks or washing basins or toilets, that's too small an area. So there are more factors than just the Coriolis effect affecting the flow of water. But if we look at storms, they kind of all tend to go along with the Coriolis effect. Anyway, link downstairs. This one is somewhat understandable, but it shows a lack of understanding of the Coriolis effect. So you're still wrong on this one, but I understand why you're wrong. Does that make sense? Well, it does to me. Okay, we're back in tinfoil headland again. I would believe in a globe if Antarctica could be openly explored without limits. Well, it can. It's fucking dangerous to do so. I mean, you could call it a desert. There's very little real water. Temperatures are way below comfort level. And yeah, there is that. But there have been people going over Antarctica. It has been done before. But not just going over it. You can cross it, but you can also circle it. You can go all the way around Antarctica. And therein lies the main issue I have with people who believe in a flat Earth. Because if you truly believe Antarctica is basically the edge of the world, how come we can go around it? Because we can. That's the main thing. If we couldn't go around it, then maybe you have a point. But yes, we have crossed it. Yes, we have gone around it. So what's your point? Yup, firmly embedded in tinfoil hat. I would believe in a globe if NASA had actually gone to the moon. And you know what? Whether NASA had or had not gone to the moon is a completely different discussion, but it has nothing to do whether the Earth is a globe, yes or no. I mean, it makes proving that the Earth is a globe a lot easier, but people knew we were on a globe even before anyone ever heard of a concept called NASA. We knew the world was a globe when flying was something only animals did, and only the animals that could fly. And the best humans could do was try to control their fall, which, in all fairness, is what we're still calling flying now, I guess. But yeah, no, I'm sorry. NASA has nothing to do with whether the Earth is round, yes or no. Humans have been around for hundreds of thousands of years, and the Earth has been around a lot longer. So I don't think humans decide what the Earth is. We recognize what it is. I would believe in a globe if someone could prove how atmosphere just fades until it's vacuum space without losing any gases. Well, you know, the easiest explanation is gravity. But I will put a link down for people who want to read more into it. It's an interesting topic and not one that I'm going to answer here fast because I can't, seriously. There are studies done into this sort of stuff to try and explain it to the average person. There is, of course, no, links down below. I'm not going to go in there now. Gravity. This one I find particularly interesting. I would believe in a globe if the sun and the moon weren't the same size relative to us. But don't you understand what you're just saying? You're saying, I will not believe it because I don't believe that something far, far, far away is a lot bigger than something really, really, really close because they both look roughly the same size. I mean, seriously? Has no one ever explained to you the concept of depth? I mean, no. Look at this.
Hello there, this is your old pal Grover, and today I'm going to talk to you about near and far. In fact, I, little furry Grover, am going to show you near and far. Okay, here goes. First, this is near. Right here, near. This is far. This is near. You see? Oh, okay, I'll do it once more for you, okay? Okay. This is near. This is far. And this is near again, okay? You want to see one more time? Oh, sure, I'm not doing anything. Okay, this is near. This is far. This is near. You got that, huh? You don't have that. Okay, this is near. And this is far. This is near. Now you must understand. You don't understand. This is far. I'll get there. Hold on. This is near. And now you understand. You don't. This is far. And this is near. You understand?
Yeah, poor Grover. But I hope the concept of near and far is now clear, and as you noticed, if someone was far, he looked smaller. Now imagine something really big being far, far, far away. It looks smaller. Anyway, let's go on to the next point. I would believe in a globe if moonlight was not cooler than moonshade. I'm not really sure what that has to do with a globe. I mean, this has to do with something else. It has to do with light reflecting off the moon or the moon blocking sunlight. The thing is, if light is reflecting off the moon, only part of that heat comes in the dark side of Earth. And during the night there is no sunlight, so the temperature cools down. And then the moonlight might have a very small impact, but we're not talking a percentage of a degree. On the other side, if you have day, the sun is shining on the earth and it's warming everything up, and then a piece of shade comes over it, which will temporarily cool it down. But it only cools it down for as long as the shade is there. So once the shade is gone, the rest of the temperature really returns. It's not that difficult, is it? But I'm still not sure what this has to do with whether the world is a globe, yes or no. Because even on a flat surface, this would be the case. And now I got to the last of their points. I would believe in a globe if gravity could explain what density already has. But here's the thing. Without gravity, density doesn't really mean that much. Well, it's not really true because you can still be dense, so it will make a subject, a material, harder or more compact. But density is also a measurement of weight. But it's only a measurement of weight when there is gravity to give it weight. For example, water has a certain weight and a certain density. Now, if you heat up water, it differs the density. For example, steam is a lot less dense than water. But what is steam? Well, steam is very, very, very hot water. So it does change the density. And because of the density change, the weight changes. But at the same time, if we take a kilo of gold, which has a pretty fixed density, and we take that kilo of gold into space where there is zero gravity, the density doesn't change, but the weight does. Does that make sense? I'm not that great an explainer in this. I'm sorry. I'll have a link downstairs and you can read up on it. But yeah, these are the points why this flat earther, the one that posted this, thinks that we do not live in a globe, and he would only believe that we live in a globe if we could argue these points. And convincingly argue these points. I'm sorry, not just say, oh, I disagree because reasons. No, explain the reasons. I have to admit that I really like the one, for example, I would believe in a globe if the stars didn't circle above us perfectly. Yeah, but they don't. Or I would believe in a globe if the Coriolis effect could actually be explained to work, but it does. That's kind of why it got its name. And but I have to think twice. For example, the globe moonlight thingy. I'm sorry, that has nothing to do with a globe. Or I would believe in a globe if NASA had actually gone to the moon. What does that have to do with the globe? I mean, whether the Earth is a globe or not has nothing to do who travels to and from it. I'm sorry, but if you live in a city, and I'm going to say I don't believe you live in that city unless you can travel to another city and prove it, that nothing to do with one another. Anyway, this is my response to this one, and it took me some time to make. Fair is fair. I hope you enjoyed this video, and I'm looking forward to your criticisms. Your critiques are always welcomed, and I'm curious whether you think I forgot something or whether I should have mentioned something else. I'd love to hear from you. Anyway, as usual, criticism more than welcome, etc., etc. Like, share, and subscribe if you feel so inclined, and I hope to see you all next time.